This question is a follow-up to the constellation question in which you plotted stars on the HR diagram. In this question, you'll combine what you know about the highest mass star in your constellation with what you know about stellar evolution to talk about the energy source and likely fate of this star. There are two key pieces of information you need to use to answer this question: the star's spectral luminosity class and its mass. The spectral luminosity class tells us where the star currently is in its life. In particular, the luminosity class tells us what part of the HR diagram the star is in. Remember that these classes range from Roman numeral 1, meaning supergiants, all the way down to Roman numeral 5 for main sequence stars. Each of these categories of stars is associated with a different energy source. Main sequence stars are stars that are fusing hydrogen in their cores, just like the Sun. On the other hand, stars that have just left the main sequence are subgiants. They have cores going through gravitational contraction and hydrogen shell fusion surrounding that. In low-mass stars, once helium fusion starts in the core, the star becomes a giant. At the end of this phase, when the core starts to contract again, double shell burning begins and the star becomes a bright giant. High-mass stars tend to go straight to supergiant from the subgiant phase, though some are classified as giants along the way. The supergiant may be going through helium core fusion, but it's more likely that it's undergoing heavy element fusion along with 2 or more layers of shell fusion above it. There are 3 possible fates for a star, and which one the star will experience depends mainly on just one thing: its mass. Most stars are low-mass stars, less than 8 solar masses. These will end their lives by forming a planetary nebula and leaving behind a white dwarf. Note that if the original star is less than 4 solar masses, the white dwarf will be made of carbon and oxygen, while if it's between 4 and 8 solar masses, the white dwarf will be made of heavier elements. Between 8 and 25 solar masses, the star will end its life as a supernova instead, leaving behind a neutron star or pulsar. Finally, stars larger than 25 solar masses have the chance to produce a gamma-ray burst. This leaves behind a black hole as the remnant. Stars in close binary systems can have more complicated options, but we don't have enough information here to tell if that's possible with the stars in your constellation, so you can stick to one of these 3 choices.